Alright, I'm going to run through a couple of homework problems from last night. We're going to start with problem number 13. So this will be 13. It said the electric current, which is measured in amps in a circuit, varies directly with the voltage, V. Okay, when you see that word varies directly, or that phrase, right away you have this formula, Y equals K times X. Y and X are two variables that vary directly, and this is the formula. K is not a variable, but it is an unknown right now. There's some constant called the constant of variation. We're going to have to figure that out. Okay, in order to figure that out, they're going to have to give us an example of an amps and a volts that go together. Now what I would do is I would replace the Y and the X with I and V. I for current, which is amps, and V for volts. And that way we won't forget about which letter was which. So we're going to use I equals K times V. As we read the problem, they tell us that when 12 volts are applied, the current is 4 amps. So we know that 12 volts goes with 4 amps. Okay, so with that example, ordered pair, we can plug that in. So we will replace the I, the current, which is the amps, with the 4, and we'll place the V with the 12. And with those plugged in, we can now solve for K, which is our constant. We've got 4 equals 12 times K. This is multiplication here, 12K. To get the K alone, we're going to simply divide both sides by 12. And so K is equal to 4/12, which is actually equal to 1/3. So K is 1/3. And now we can go back and we can write this formula right here, I equals KV, a little more specifically, and we can say that I, the amps, is actually equal to 1/3 times the volts. And now we have a formula that can be used. So in the previous problems up above in your homework, 1 through 12, they really asked you to do that much. They said first find the constant of variation. Well, the constant of variation was K, I've got that. Secondly, they said find an equation of variation, and having this I equals 1/3 times V, basically replacing the K now with the 1/3 and keeping the I and the V as variables, is the equation of variation. It's a formula that could be used now to find another example, another order pair of volts and amps that go together. Well, on problem 13, they ask us to predict the current when 18 volts is applied. So we're going to go ahead and use our formula, and we don't know what I is. They want us to predict the current, predict the I, when the volts was 18. So we're going to replace the volts with 18 and solve our formula. And here I is already isolated, so we just need to simplify 1/3 times 18, which is 6, and that's measured in amps, and that is our answer. So 6 amps is the number of amps we would expect when we applied 18 volts. Alright, so that was number 13. Let us move on to one of the other examples. I want to do one that said varies inversely. So let's see, how about number 16, the last one on your homework last night. They tell us that the time required to empty a tank varies inversely. As soon as you see varies inversely, we're going to copy this formula. Y equals K divided by X. Now as we read in here, we see that we're dealing with time and a rate. So I'm going to rewrite this with a T in for the Y and a R in for X. Now something I didn't really state as I was doing the first example that let's state right now. When you've got these two other letters, T and R, that we're going to use, it does not matter which one you plug in for the Y or X. Okay, just from here on, stay consistent. Okay, so T equals K over R is fine. If you did R equals K over T, that would be fine. So the T and the R can trade spots, no big deal. Just be consistent from here. Alright, so we know these vary inversely. They tell us that a pump can empty a tank in 45 minutes at the rate of 600 liters. So I have a couple pieces of information that are paired together. 45 minutes and a rate of 600 kiloliters. So KL per minute, kiloliters per minute. So that goes together. With those two, that's an ordered pair. I can plug that in. Okay. Let's see, the time we will make 45. I don't know what the K is right now. It's some unknown constant, but I know the rate at which my pump is going to pump is 600. And now I'm going to use this equation to figure out K. I'm going to multiply both sides by 600. That cancels the 600 on the right. In the denominator, I'm going to multiply by 600 on the left. And 45 times 600 is simply 27,000. So now I have my constant of variation. And it's some constant that's associated with it. And basically what that's telling me really is that I've got 27,000 kiloliters that need to be pumped out. So with that, we can write a formula. We can take this T equals K over R that I've got right here, and I can write it now a little more specifically. I can say time is actually equal to 27,000 divided by the rate at which you're pumping. Okay, so we found, if you think back to the beginning of your homework, they said find the constant of variation. That's the 27,000. It's the K you find out when you plug in the example order pair. They said find an equation of variation. That's this right here, rewriting the T equals K over R with the K plugged in, but keeping T and R as unknowns. That's a formula that could be used to now find any other example order pair. And they ask us here, how long will it take the pump to empty the tank at a rate of 1,000 kiloliters per minute? So they're asking for a time, being given a rate. So let's go ahead and use this formula now, and we'll figure it out. So what is the time? T is still unknown. If our rate is 1,000. Well, they made this pretty easy on us. 27,000 divided by 1,000 is 27. Our units have been minutes. So there you go. Now I've got a couple examples worked out of a direct variation and an inverse variation problems, so that should help you try to do a few more examples today.